Dear students, Sai Ram to all of you. In previous class, we studied about momentum, rate of change in momentum and Newton's second law of motion. So momentum is the product of mass and velocity. Its unit is kilogram meter per second. We also studied the rate of change in momentum depends not only on the magnitude of force but also the duration of force, the time during which the force acts. So based on this, we stated Newton's second law of motion, that is, the rate of change in momentum of an object is directly proportional to the external unbalanced force in the direction of force. That is what we studied in the previous class. So today we are going to derive the mathematical formulation for second law of motion. Mathematical formulation for second law of motion. For second law of motion. So now we are going to derive the mathematical formulation of Newton's second law of motion. You consider an object of mass m. Consider an object of mass m moving with the initial velocity u. Moving with the initial velocity u. It is uniformly accelerated to velocity v in time t by the application of a constant force F. So these are the quantities required for us. Once again, consider an object of mass m moving with the initial velocity u. This object is uniformly accelerated to velocity v by the application of a constant force F in time t. So let us start with initial momentum. Initial momentum. Initial momentum, let us take it P1, and you know initial momentum is the product of mass and initial velocity. The mass always remains same, so we should consider only velocity. So initial momentum is equal to mass into initial velocity, that is mu. M is the mass, u is the initial velocity. Now what is final momentum? Final momentum. Let us take it P2. Final momentum is mass into final velocity. Mass into final velocity, that is mv. M is the mass, v is the final velocity. Then what is change in momentum? Change in momentum is final momentum minus initial momentum, that is P2 minus P1. P2 minus P1. That is nothing but mv minus mv. mv minus mv. So change in momentum is final momentum minus initial momentum, that is mv minus mv. Then what is rate of change in momentum? Rate of change in momentum, that is change in momentum divided by time, that is rate of change in momentum. So change in momentum mv minus mu divided by t. This is the rate of change in momentum. Rate of change in momentum. Once again see, an object of mass m moving with initial velocity u. It is uniformly accelerated to velocity v in time t by the application of a constant force F. So initial momentum is mu, mass into initial velocity. Final momentum is mv, mass into final velocity. Change in momentum is final momentum minus initial momentum. That is mv minus mu. Rate of change in momentum is change in momentum divided by time, that is mv minus mu divided by t. Now, what does second law tells? Second law states that this rate of change in momentum is directly proportional to the external force. So, according to Newton's second law, according to Newton's second law, F proportional to mv minus mu by t. See? According to Newton's second law, rate of change of momentum is proportional to the external force. So we get F proportional to mv minus mu by t. This I am writing as a, right, that is F proportional to v minus u by t. M I am taking as common, so v minus u by t. Right? We know v minus u by t is the acceleration a. So F proportional to ma. Since v minus u by t is equal to a. F proportional to ma, because we know v minus u by t is a change in velocity by time is nothing but acceleration a. Now this proportionality can be changed into equality by adding a constant. So we are adding a constant k. We write F is equal to k m a. F is equal to k m a, where k is the proportionality constant. K is the proportionality constant. K is the proportionality constant. So we got F is equal to k m a. F is equal to k m a. Now, F is the force, k is a constant, m is mass and a is acceleration. We know the units of mass and acceleration. We know the unit of mass and acceleration. Yes, unit of mass is kg. Unit of mass is kg. Unit of acceleration is meter per second square. Unit of acceleration is meter per second square. Now k is a constant, so it does not have a unit. And you know force is a new quantity introduced by Newton. Now Newton wanted to derive a unit for force. Newton defined the unit of force in such a way that K becomes 1. Newton defined the unit of force in such a way that K becomes 1. For that he defined one unit of force, is that amount which produces an acceleration of 1 meter per second square on an object of mass 1 kg. Yes. So Newton defined the unit of force in such a way that K becomes 1. For that he defined like this. What is 1 unit of force? 1 unit of force is that amount which produces an acceleration of 1 meter per second square on an object of mass 1 kg. Okay? That is, see, we have F is equal to km, let me here, F is equal to kmk. This is equation number 1 for us, right? Now, according to this, F is equal to kma, that is 1 unit of force. According to this definition, 1 unit of force is equal to k is a constant, into 1 meter per second square into 1 kg. See everywhere? Here it is 1, this is 1, this is 1. So accordingly k is equal to 1. We get k is equal to 1. So we have here equation number 1. You substitute k is equal to 1 in equation number 1. Substitute k is equal to 1 in equation 1. What we get? We get F is equal to ma. So this is the mathematical formulation for Newton's second law of motion. F is equal to ma. I was telling you in the previous class, the first law of motion tells us about the force, the cause of motion. The second law helps us how to measure force. So we have the formula F is equal to ma. When a force acts on an object, it gets accelerated. If we know the acceleration and if we know the mass of the object, we can measure that force by using the formula F is equal to